All right, let's go over today's check your understanding. So it says, is it more expensive to live in California or Florida? Monthly cost of living expenses for California are approximately normal. So California are approximately normal with a mean of $10,800 and a standard deviation of $3,200. Monthly cost of living expenses for Florida. Okay, so Florida is also approximately normal with a mean of 8,500 and a standard deviation of 2,700. Suppose we select independent simple random samples of 16 residents of California and 9 residents of Florida, so 16 for California. Calculate the sample mean monthly cost of living for X bar C and X bar F. Part A says, what is the shape of the sampling distribution of X bar C minus X bar F? So the sampling distribution or the mean of the sampling distribution for California minus the mean of the sampling distribution for Florida. And why is that? So if we go back up to our information here, we can see that California was approximately normal and Florida was approximately normal. So since both populations are approximately normal, we can say that the difference will also be approximately normal. We can say that both of the populations are approximately normal. So the sampling distribution of, let's write that there, is also normal. So I'm writing that in. I'm writing in X bar C minus X bar F. So I would write approximately normal. Both of the populations are approximately normal. So the sampling or the sample distribution of X bar C minus X bar F is also normal. All right. Part B, find the mean and standard deviation of the sampling distribution of the difference. Okay. So the mean is pretty simple. So the mean of X bar C minus X bar F is equal to the mean of the population for California minus the mean of the population for Florida. So just plugging in those numbers, 10,800 minus 8,500, we get $2,300. And I just pulled those straight from the problem up here. All right, the standard deviation is similar to what we did before. So standard deviation of X bar C minus X bar F is equal to the square root of standard deviation of California squared divided by the sample size of California plus the standard deviation of Florida squared divided by the population or the sample size for Florida. So, oops. So let's plug in those numbers. We've got the square root of 3,200 squared divided by my sample size of 16 plus 2,700 squared divided by You should get 1,204.16. I strongly encourage you to check this in your calculator to make sure you got the same answer. If not, make sure you ask questions about where or what you might be doing wrong. Okay, part C, calculate the probability that the average monthly cost of living expense of the 16 randomly selected California residents is less than the average monthly cost of living expense of the 9 randomly selected Florida residents. So what is this asking me to find? Okay, so if there's no difference between the cost of living for California and the cost of living for Florida, the difference would be 0. Since I'm looking for California to be less than the cost for Florida, remember I've been looking at X bar C minus X bar F. If California is less than Florida, then I'm looking for that number to be less than 0. So I'm looking for the probability that X bar C minus X bar F is less than 0. It's going to be negative. So let's figure that out. I've got a normal distribution. We've already established that with a mean of 2,300, a standard deviation of 1,204.16. Okay. So if this is 2,300, I want to know what's the probability of being less than 0. So I want to show you, remember all of these scores follow the same basic format, the value minus the mean divided by the standard deviation. So even though this formula looks gross, bar C minus X bar F, okay, that's still just the value that we're interested in, minus the mean of California minus the mean of Florida, okay, divided by the standard deviation, which we just did up above. We've got the square root of the standard deviation of California squared divided by the sample size of California plus the standard deviation of Florida squared divided by the sample size of Florida, okay? But ultimately, we've already found all of these values. The value I'm interested in is 0 minus the mean of 2,300 divided by the standard deviation of 1204.16. And so that gives me a z-score of negative 1.91. And then I can go to table A and I get 0.0280. And again, this is where I really encourage you to use that normal CDF function in your calculator, and then you don't have to worry about all of this formula, okay? All you have to make sure is that you're interested in your value, the mean of your sampling distribution, and the standard deviation of your sampling distribution. All right, if you have more questions, as always, make sure you're asking them in class.